How many minutes?
Hello, good evening, everyone. Yeah, welcome to today's class. Today we shall be looking at change of state, latent 8. As you can see on the screen, we have objectives of the topic, and what this objective is talking about is probably the area of concentration or area to consider while preparing for any examination while studying this topic. Now, what's the essence of this? I arrange this so that when you are preparing for this, you will not just focus on only calculations. Some other part of the topic that you can just also consider are what we have on the screen here. Now, let's quickly run through them. The first objective there is definition of terms. That is, in any examination, you may be asked to define latent heat itself. Also, you may be asked to talk about the latent heat of fusion. Also, you may be asked to explain the term latent heat of vaporization. You can as well be asked to look at specific latent heat of fusion and specific latent heat of vaporization. And all these, they are definition of terms that are associated with this topic, latent heat. So, in preparation for any examination while studying this topic, you may need to consider all these as well, as you can come across them in form of explanation, definition, and probably sometimes an examiner may also want to test your knowledge of this part. And the second objectives that we have here, we have boiling and evaporation. You can as well be asked to state the distinction between boiling and evaporation. You may be asked to explain those two terms in any examination as well. For example, your WAEC, your NECO, and any other examination, you may be asked to state the distinction between boiling and evaporation as well. Also, you may be required to use the knowledge of molecular theory to explain terms such as fusion, boiling, and evaporation. This is another thing that you need to take note of. Okay, and we can as well consider another objective that we have here. You can as well be asked to also discuss terms such as vapor pressure and relative humidity and some other related terms to this aspect as well. So let's while studying for this topic, try as much as possible to also cover this area. But tonight what we are looking at is latent heat, and that is what we are going straight to. We are going to be solving calculations from past examination questions such as WAEC, NECO, and UTME. But to start with, what is the definition of latent heat itself? Latent heat is the quantity of heat supplied or removed from a substance in order to change its state without a change in its temperature. Now, what do I mean by this? In our previous class, we discussed heat capacity of a substance, that is, it required to raise the temperature of a substance by 1 degree Celsius or Kelvin. But when it comes to latent heat, when heat is applied to a substance, it will get to a point that the heat supplying to the substance would not increase the temperature of the substance, but change the state of the substance. So this type of heat is what we call the latent heat, and any substance can experience this at their melting point or boiling point. That is, the heat supply at that particular time is used to break the bonds between the molecules of this substance, rather than increasing the temperature in this substance. So that is why it is called latent heat. And we are going to be looking at two major types of the latent heat tonight. We are going to consider latent heat of vaporization and latent heat of fusion, and we're going to see calculation on them. Now, as for latent heat of fusion, as we all know, fusion is another term used for melting. So latent heat of fusion is quantity of heat required to convert a substance from its solid state to liquid state without a change in temperature. That is a latent heat of fusion. And as we have in previous classes when we were discussing specific heat capacity, we also have specific latent heat of fusion, which is the quantity of heat required to change a unit mass of a solid to liquid at its melting point without a change in temperature. Also, we have a latent heat of vaporization, which is the heat required to change a liquid to gas at their boiling point without a change in temperature. We also have specific latent heat of vaporization, which is a quantity of heat needed to change 1 unit mass of a liquid to gas at their boiling point without a change in temperature. So those are the definitions that are very important. You can as well consider studying boiling, evaporation, and also their molecular theory explanation. Without wasting much of our time, let's go straight to past examination questions that has to do with this topic. We'll be dealing with calculation basically, and if you really need a theoretical background, like I mentioned in the last class, you can as well try and get a copy of a REVAMP Physics e-note. And to get that, you can check the description of this channel or the description of this video. You're going to see a link to get that, or just drop a comment by requesting for my contact at the comment section. The comment section is open. Okay, let's move straight to the major things that we are considering today. Let's quickly solve some examples. In the first example that we have here, the question says, how much heat is required to change 200 grams of ice at 0 degrees Celsius to water at the same temperature? Let me take that again. The question says, how much heat is required to change 200 grams of ice at 0 degrees Celsius to water at the same temperature? And this question is a past NECO question, NECO 2006. And we have a constant given, which is a specific latent heat of fusion of ice, and that is given as a 336 joule per gram. Okay, in order to solve this problem, remember when we were dealing with heat capacity, we said quantity of heat supplied to a body is given as MC delta theta. But when it comes to the case of latent heat, the quantity of heat supply into the system to break the bonds or change the state of the body is given as ML, where L represents the latent heat. But in the case of this question, we are dealing with latent heat of fusion because we are talking about melting of ice. So we can just add subscript F just to differentiate between latent heat of fusion and latent heat of vaporization. And according to this question, our mass is given in the question as 200 grams, while we have specific latent heat of fusion given as 336 joule per gram. Okay, which means we can easily substitute all this into this formula by having 200 multiplied by 336, and that make our Q to be equal to, can quickly press your calculator to get the value of that, and that will give us just a moment, and that will give us 67,200. That is 67,200 joule. Okay, that's the value of that. That's the quantity of heat needed to melt 200 grams of ice at 0 degrees Celsius. Okay, let's consider the second example that is similar to this. The quantity of heat that is required to boil up 2 kilograms of certain liquid completely, that is 1 million joule of heat is needed to boil up 2 kilograms of a certain liquid. And neglecting the heat lost to the surrounding, we have to calculate the latent heat of vaporization of the liquid. Now, what are the given parameters in this question? We have our Q given as 1 million joule, and we have the mass of the liquid given as 2 kilograms, and we were asked to find the latent heat of vaporization of this liquid. And using Q equal to M LV, and making LV the subject of the formula, we can easily have our LV to be equal to Q over M, and this will give us 1 million joules of heat divided by 2, and we can easily press a calculator to get this. We may not even need to press the calculator to get this value. So this will be equal to 500,000 joule per kilogram. So that is the specific latent heat of the substance. Let's quickly go through this again. You can see 1 million so we have to find the latent heat of vaporization of the liquid, and this UTME making LP the subject of the formula. We have Q over M, and our Q given in the question is 1 million, while M is 2 kilograms. We're able to divide that, and we have a 500,000 joule per kilogram as our final answer. Okay, let's go for more examples. Now, the first two examples that you can see here, these are the types that you come across in objective, one in theoretical aspect of our examination. Okay, let's look at this example 3. In example 3, we are to determine the quantity of heat needed to melt 200 grams of ice at minus 15 degrees Celsius to water at 10 degrees Celsius. Now, first thing that we need to consider is we need to look at all the phases that are involved in this change of state from ice to water. As you can see, there will be a change of temperature here, which means the heat required to do this is not just latent heat. We are going to have more than latent heat in this. Now, how many phases are we considering here? First of all, we need to consider, okay, let's just write down the given parameter in this question. We have our mass given as 200 grams, and just because all other constants are given in joule per kilogram, let's convert our mass to kilogram. So we have it as 0.2 kilogram. Now, the ice is moving from minus 15 degrees Celsius to water at 10 degrees Celsius. So before this ice can melt, the melting point of ice is 0 degrees Celsius, which means we will need heat to raise the temperature of this ice from 15 degrees Celsius to 0 degrees Celsius. That is the first part of this question. And heat needed to raise the temperature of the ice from minus 15 degrees Celsius to 0 degrees Celsius. Let's call it Q1. And that one is from minus 15 degrees Celsius to 0 degrees Celsius. And we can quickly calculate that. And in order to calculate that, we are going to have our Q1 to be equal to MC delta theta. Remember, I mentioned that we are going to need more than latent heat here. That is, we are changing the temperature of the ice. So the heat supply here is not latent heat because it's not breaking the bond. It's only increasing the temperature of the ice. So this can be calculated by using the mass of the ice, which is 0.2, multiplied by specific heat capacity of the ice as given by in the question. We have it as 2100, and change in temperature is rising from minus 15 to 0 degrees Celsius. So we are going to have minus, sorry, let me use another symbol for that. So we're going to have 0 minus 15, and we can simplify further by having our Q1 to be equal to this. By pressing our calculator, this will give us 6,300 joule. This is the first phase of taking this ice from minus 15 degrees Celsius to water at 10 degrees Celsius. The second phase, that is when we apply heat to melt this ice to water at 0 degrees Celsius. And let's say the heat applied at that point, let's call it Q2, and Q2 is ice at 0 degrees Celsius to water at 0 degrees Celsius. Okay, that is ice at 0 degrees Celsius to water at 0 degrees Celsius. Let's quickly calculate Q2. You can see our Q2 will be equal to, now at this point there won't be change in temperature, so the heat we are applying to break the bond between the molecules of the solid, that is ice, is latent heat, and we are going to make use of our latent heat of fusion of ice in this particular one. So now our Q2 will now be equal to the mass of the ice, which is 0.2, multiplied by specific latent heat of fusion of ice, and in the question that is given as 336,000, and with the help of calculator, our Q2 will give us with the help of calculator, our Q2 will give us 67,200 joule. And the next phase is to take the water from 0 degrees Celsius to water at 10 degrees Celsius. Okay, and the heat needed to do that, let's call it Q3, and that is water at 0 degrees Celsius to 10 degrees Celsius. And to do that, this one involves a rise in temperature. So we can see Q3 equal to MC delta theta, and Q3 is now equal to mass of the ice. Remember, it has turned to water, but the mass will not change no matter the form it is. Mass remain constant. Okay, specific heat capacity of water is 4,200, as you can see, and change in temperature this time around equal to 10 minus 0, because we are taking it from 0 to 10 degrees Celsius. And with the help of our calculator, our Q3 will be equal to 8,400 joule. Now, these are the three phases that were involved, but they asked for the total heat needed to take it from 15 degrees Celsius to 10 degrees Celsius. So if you call that one ordinary Q will be equal to Q1 plus Q2 plus Q3, and that means we are bringing all the heat contents together, and it means our Q will be equal to, the first one is 6,300, our Q1 is 6,300. The second one is 67,200, while the third one is 8,400. And with the help of our calculator, we have our Q to be equal to 81,900. 9,900 joule, and that is also equal to 81.9 kilojoule. So that is the heat needed to convert the ice from temperature of minus 50 different phases together to have the total heat needed to change ice from minus 15 degree to 10 degrees Celsius. Okay, let's look at one more example that has to do with another source of heat, which is electricity. Okay, this one is coming from WAEC 2019, and the question says, a 40-volt electric heater is used to supply a current of 12 ampere to a 40-volt electric heater is used to supply a current of 12 ampere for 1,400 seconds to a body of mass 1.5 kilogram at the melting point of the body. Now, the body melts and its temperature rises through 60 degrees Celsius in another 72 seconds. We have to determine the latent heat of fusion of the body and specific heat capacity of the body. Now, first thing we are going to do is to write out the given parameter. Now, the first thing we have here is that the voltage of the heater, which is equal to 40 volts. We have the current of the heater, which is equal to 12 ampere, and the time for the body to melt, we can refer to that as T1, and that is equal to 1,400 seconds. Now, the mass of the body in question equal to 1.5 kilogram, and after the supply of the heat, the body melts, and later the temperature rises by 60 degrees, that is delta theta is equal to 60 degrees Celsius, and that happened in another 72 seconds, which we are going to refer to as T2. So we can see the two phases in this particular one. The first phase is melting phase, and the second phase is the phase whereby the temperature increased. And they now ask us to find the latent heat of fusion of this body. And in order to do that, we are going to consider the first phase. We are going to consider the first phase for the first question, because that is where fusion occurs. That is where melting occurs. And heat needed to cause the melting is supplied by the heater. So we can say IVT, which is electric energy, or heat energy from the heater equal to MLF. This is fusion phase, that is melting phase. And remember, the T here is 1400, which is T1. So we can substitute all the values into this equation. Our I is 12. We have 12 multiplied by our V, which is 40, multiplied by 1400, and that will be equal to 1.5 multiplied by LF. We can make our LF the subject of the formula, and this will give us 12 multiplied by 40 multiplied by 1400 divided by 1.5, and with the help of our calculator we can easily get the value of our LF to be equal to, let's quickly press that one on calculator. And that will give us 448,000. This will give us 448,000 joule per kilogram. Now that's the first phase of this question, where they ask us to find the latent heat of fusion of the body, and that is when fusion takes place, and that will so we can use that to calculate the heat capacity. I would like to say this again. If you are part of this class tonight and you are yet to subscribe, please kindly do that tonight, so that you get notification whenever our class is on like this. Click a subscribe button and also click on notification button, and if this class has added any value to your knowledge, please kindly click give this class a thumbs up. If you need a comprehensive note that covers every topic in physics from grade 10 to 12, kindly ask for my contact in the comment section, or you just check the description of this video or the channel. You're going to see a link to a book called REVAMP Physics E-Notes. This is a comprehensive note that covers all the topics you've been doing right from SS1, even including all the examples that has been treated in this video, and every definition that was discussed at the introductory part of this video. Everything is in this note, and this note is something that you can use that can assist you in having a very good grade in any of your examination. Okay, let's consider the second part of this question. We have to find the specific heat capacity of this substance, and we are still supplying the same heat, but the duration is just the difference. So we can still use our IVT, but this time around T2, because the temperature rises in another 72 seconds. We can say IVT2 equal to MC delta theta. So making C the subject of the formula, we can have C to be equal to IVT over M delta theta, and with that we can say our C equal to, our I according to the question is 12, our V is 40, T2 is 72, and our M is 1.2. Change in theta is 60 according to this question, and with the help of our calculator, pressing our calculator, we are going to have the value of specific heat capacity of this substance to be equal to 384 joule per kilogram per Kelvin, and that's the final answer for this question. Once again, I would like to encourage you guys, whenever you are on live classes like this, you can just try and have writing materials that you can put some things down, and also go through the video again and again. And if you have any question, feel free to drop your question at the comment section. And like I said earlier, if you are yet to subscribe to this channel, please do click on subscribe button and also click on notification button so that you get notification whenever we are having a live classes like this. And also, if you need more information about physics, you can get the REVAMP Physics e-notes. It's a comprehensive notes. It's a summarized note that is having detailed information of whatever you need to know, right from year 10 to year 12. And to get that, you can drop a comment to request for my contact, or you can check the description of this channel. You're going to see a link to the note there. And if in case you think you need a professional to attend to you on one-on-one section via Zoom or Google Meet or WhatsApp, you can reach out to me by requesting for my contact. I do have virtual classes with students as well. That depends on your need. So you can just reach out to me, and all those one will be handled. Once again, thank you for being part of this class today. Thank you, and God bless you.